So we're going to start with the vertex, and the vertex is a coordinate, and once we have that vertex coordinate, you'll be able to state the axis of symmetry, which is simply x equals the x value of your vertex. So to find the vertex, you're going to have to use x equals negative b over 2a, okay? And I would simply start by, instead of having a b and an a, replacing it with parentheses and then plugging in the values of b and a. So b, if you look at the standard form quadratic trinomial, the b value is 4. So let's plug in a 4 for b, and the a value is 2. So plug in a 2 right there. So we end up with x equals negative 4 over 4, which really equals negative 1. So negative 1 is our x value of our vertex, and that is simply the x value of our vertex coordinate. Now, if we want our y value of our vertex, we're simply going to take that x value of negative 1, and we're going to plug it in right here into this x spot and into this x spot. So we're going to take the negative 1 and plug it into both x's, work it out, then we'll be able to find our y value of our vertex. So far we have the x value. Let's plug it all into the equation to find the y value. And the way to do that would be to rewrite the whole equation, but instead of x's, write parentheses, and then plug in your negative 1. So I already have the equation set up with parentheses. And let's plug in our x value of negative 1. Negative 1 right in there, and negative 1 right here. And of course we're going to start with exponents. Negative 1 squared, that's positive 1. So you really have 2 times 1, which is 2. Then right here we have 4 times negative 1, that's negative 4. And we also have a minus 6 at the very end. So our final y value will be negative 8. So our vertex is negative 1, negative 8. So our vertex is negative 1, negative 8. And if we know the vertex already, we might as well graph it. And I went ahead of time and graphed the negative 1, negative 8. It's down here. Probably make it bigger. There's a vertex, negative 1, negative 8. And through the vertex, there's a vertical line that's called the axis of symmetry. So I'm just going to make a dotted line going right through this vertex, all the way through. And what is this axis of symmetry equation? X equals what? Negative 1. So you can say axis of symmetry, x equals negative 1. So we so far have found the vertex and the axis of symmetry. And the next thing on our list is to find more coordinates, either with a pattern or an XY table. So the question is, can I use a pattern on this quadratic equation?
No.
Why not? The a value is 2. And the only way you could use the pattern, and here's the pattern by the way guys, the pattern is 1, 1, 2, 4, 3, 9. And the only way to use that pattern is if your a value is 1. Or negative 1. Correct. Well, you know what? You technically could use the pattern. Alright? You could use the pattern, but it just becomes a lot more complicated. Now, we know that this pattern works when you have an a value of 1 or negative 1, right? And we know that this quadratic equation has the a value of 2. All right, so this one actually has the a value of 2, not 1. So if you really wanted to force the pattern, you could actually, let me move this out of the way. You could actually modify the second set of numbers by multiplying them by 2, and you would get 1 times 2 is 2, 4 times 2 is 8, and 9 times 2 is 18. So technically you could use the pattern, but it would be a modified pattern of 1, 2 instead of 1, 1, of 2, 8 instead of 2, 4, of 3, 18 instead of 3, 9. Yes? So the reason why we're modifying the second set of numbers here is because the original pattern 1, 1 2, 4, 3, 9 came from the parent graph y equals x squared, where your a value was 1. Okay, that's the original parent graph, and that's where the pattern came from, the 1, 1, 2, 4, 3, 9. So if your a value is no longer 1, let's say it's 2 in this case, yeah, you'd have to modify your second set of numbers here on your patterns, so by multiplying it by 2. So you'd get 1, 2, 2, 8, 3, 18. Now obviously modifying the patterns is not the best way to go, because sometimes you'll have a value of 1/2 or 1/3 or 1/4. Then you'd have to multiply not 1, but this 1 times 1/4, and you get 1/4 right here. Multiply the 4 by 1/4, and you get 1. 9 by 1/4, you get 9/4. So it does get ugly. So the best time to use a pattern is when your a value is 1. If you want to force it, you could force it like right here. But let me go back, and let me go with the XY table. So going back over here, let me jump to an XY table. Now, I already know that my axis of symmetry is right here at x equals -1, okay? So I need more points. It would be a great idea to pick points that are on the same side of the axis of symmetry. So here's my axis of symmetry. I'm not going to pick -2 and +1, because those are on opposite sides of the axis of symmetry. You want to pick at least 2 values that are on the same side of the axis of symmetry. So which number would be the easiest to plug in? What would you say? 0 would be easy, right? And 0 is on the left side of the axis of symmetry or on the right side of the axis of symmetry? Right. It's on the right side. Okay, so let's just keep that in mind. Plugging in 0 is cake. Check it out. 0 squared times 2 is still going to be 0. 4 times 0 is still going to be 0. And 0 plus 0 is 0. Minus 6, what do you get as an output? -6. Okay? So the coordinate 0, 6 is an actual coordinate. What other number would you like to plug in? 1. Because that's also on the right side. Okay, so let's plug in 1. You might want to show your work. I don't know. It's up to you. 2 times 1 squared plus 4 times 1 minus 6. So plugging in a 1 right there, you'll get 1 squared, that's 1. So you have 2 times 1 plus 4 minus 6. So that's really going to be 2 plus 4 minus 6. 2 plus 4 minus 6? 0. Right? 2 plus 4 is 6. Minus 6 is going to be 0. So for my input 1, I get an output 0. That's another coordinate. You know what? Might as well, since we're on a roll here, bless you. Let's plug in the number 2. All right? So let's do this in our head here. 2 squared. What's 2 squared? 4. And what's 4 times 2? 8. So let me just put an 8 right here just so I don't lose track. And then let's plug in a 2 right here. What's 4 times 2? 8. So we have plus 8. And then we have minus 6 at the end. So let me write that. So 8 plus 8 is 16. And 16 minus 6 is 10. So when I plug in a 2, I get out a 10. So I have those 3 coordinates. Put the parentheses around them. Let me graph them now. 0, -6. It's pretty easy to do. 0, -1, 2, 3, 4, 5, 6. Let me zoom in a little. Zero, -6 is right there. And what's the other coordinate we got? 1, 0. That's easy. 1 on the x, 0 on the y. And the last one is 2, 10, huh? So if I do go 1, 2 this way, and then 10 all the way up to the very edge, because it's a 10 by 10 graph, 210 will be way up here. You guys following me? And now, what could we do? Because so far, we have this side of the parabola. So what could we do to find the other half of this parabola? Map it over to the other side. Reflect it on the axis of symmetry. So if I do map it over to the other side, what do I mean by mapping it over? Here's the axis of symmetry. This is 1 unit away from it, so go 1 unit this way and put a dot right there. This guy is 1 unit, 2 units away, so go 1, 2 and put a dot right there. And if you go up to the very edge we see that it's 1, 2, 3 units away from the axis of symmetry. So go 1, 2, 3 this way. Put a dot right there. And ladies and gentlemen, you have your perfect parabola. If you could draw better than me, because mine's ugly. What do you think? Now let's just say that you did want to go back and use this new modified pattern, because we know that our A value is 2 and not 1, and we went back and took the second pair of numbers on the pattern and multiplied them by 2. 1 times 2 is 2. So if you go 1, 2, and then 2, 8, and 3, 18, that's your new pattern. Let me write that over here. 1, 2, 2, 8, and then 3, 18. So if I go back over here, from the vertex, if I go 1, 2, I really do end up at that coordinate. If I go back to the vertex and go 2 over and 8 up, I really do end up at that coordinate. Or if I go 1, 2, 3 over and 18 up, I really do end up at that coordinate right there. So it's up to you if you want to use XY table, or if you want to use the modified pattern of 1, 1, 2, 4, 3, 9. I'd probably go just with the XY table. It's not that difficult to do. What else is there? I threw in a couple of extra questions. Let me see. Oh yeah, we still need vertex form. So let me get this out of the way. Let me delete this. Boom. So we have our vertex right here. Our vertex was -1, -8. If I wanted to write it in vertex form, I think I already have, oh yeah, I do have it written down right here. Vertex form. Sorry, moving everything around. So if we have our vertex and we know our vertex form, all we need is our A that's in red, our H, and our K that's in red. So where do we get our A value from? From the original, right? Your A value is right here. The A value is 2. Okay? And what about the H and K? Well, the vertex that you just found, that's a H value and that's a K value. So let me zoom out. And now let me write down the equation here. So you have y equals what? 2 parentheses x. Anybody? Okay, and let me go show on my work minus -1, right? And I should probably have done the -1 in red to show that that's my H value. Plus K is simply going to be a -8 because our K value is -8. And I forgot the square. So my final equation in vertex form, y equals 2 parentheses x plus 1 squared minus 8. That's vertex form right there. Question? And for the final question here, we're going to do, let me get rid of this guy. For the final question, we're going to talk about the domain and range. A lot of people get confused with domain and range. It's this easy. Domain is your x values, range is your y values. Okay? So the domain, since we're talking about x's, right? X's are inputs. So you can look at this visually, and you see this parabola, even though it goes up, it never goes straight up. It's never going to go straight up. It always continues to grow out to the right and to the left, but just keeps going further and further up, right? So what is the domain value?
All real numbers.
X equals all real numbers. So you're going to say X equals all real numbers. Another way of concluding that your domain values are all real numbers is when you look at this original equation. Yeah, on the XY table, we plugged in 1, we plugged in 2. Could you plug in 3? Yes. Could you plug in 4 into your x's? Yes. Could you plug in 1,000? Yes. 1,000,000? Yes. Could you plug in a -1,000,000? Yes. So your domain values is really what you could plug in. You could plug in anything you want, right? Positives and negatives, and that's why your domain value is all real numbers. Time for our range. Our range values are our y values. Now, when we're talking about where this graph is at in terms of y, does this graph exist at y equals 10? Absolutely. There's 2 dots up here. Is there at y equals 0? Yes. Y equals -6? Yes. Y equals -8? Yes. Y equals -10. Does this graph exist at y equals -10? No. So it starts existing here and it goes up forever. So the range is y greater than or equal to -8.